Hello and welcome to today's webinar, The Rising Need for Managed Services in Open Source Management. My name is Stacy Potter and I'm the Marketing Manager here at Flexera, and I'll be moderating today's webinar. Before we get started, I'd like to take care of a couple of housekeeping items. Most of you will be logged on and listening to this through your computer audio. If you have any issues with the sound quality at any point during the webinar, this can usually be resolved by refreshing your browser. If refreshing doesn't do the trick, please reach out to us via the chat window and someone will help you resolve the issue immediately via the chat function. I'd also like to point out that you can ask a question at any time during the event via the chat window, and we'll answer them at the end of the presentation during our Q&A session. We are recording the webinar today, and each of you will receive a link to the recording and a PDF of the slides within the next 24 to 48 hours. It will also be available for replay on our website. I'd like to start by introducing our speakers today. Alex Rybak is the Director of Product Management for Flexera's software composition analysis products. He joined Flexera via the Palameda acquisition, where he worked in several critical roles including professional services, pre-sales, solutions engineering, and product management. Prior to Palameda, Alex spent 7 years at Selectica in various roles. Alex earned his BS in Mechanical Engineering from the University of California, Davis, and an MBA from San Jose State University. Martin Callanan is the founder and director of Source Code Control and has over 20 years experience of providing organizations with strategies to manage business risks associated with open source software such as IP compliance, security vulnerability management, and procurement. Martin is actively involved in the open source software industry to help create best practices and industry standards for the adoption and management of open source-based software through organizations such as Tech UK and Open UK Industry Association for Free and Open Source Software. And with that, Alex, I will hand it over to you.
Great. Thank you, Stacy. Hello, everybody. Thank you for joining. I am Alex Rybak. So Martin and I are going to do a little bit of a back and forth today. I'm going to start off by talking a little bit about the introduction to open source, talk about how open source comes into organizations through the software supply chain, a little bit about the current status of the industry, and then Martin will take over to talk about the challenges of managing open source, how you can achieve continuous compliance through the use of managed services, and then I'll finish up by talking about how we generally recommend our customers get started. So if you look at the state of open source today, it's everywhere. It is in applications, it is in IoT devices, it is in enterprise applications, so forth. In the past, it used to be predominantly visible in certain industries or certain verticals. Today, it's ubiquitous, it's everywhere, and therefore it's critically important to have a program in place to be able to manage the use of it. Open source has become so prevalent that it has fundamentally changed the way that software is built. So historically, you would have an engineering team. They would do all the work. They would write all the code. It would get compiled, and it would get shipped to a customer. Today, it takes an army. There's open source being developed by a community. There's open source being created by a community. It's being modified by your own internal development team. It's being put into your products with your own commercial code on top of that. And then finally, it's being released to the market. So that adds a lot of complexity, and there's a lot of hands on the code, and therefore it becomes critically important to be able to understand the composition of the products as they go out the door. So according to Gartner, more than 95% of IT organizations leverage open source, and we're seeing that number creep up to close to 100% at this point. We typically see anywhere between 50 to 80% of the code that we look at as part of our audit practice that consists of open source packages, and there's many reasons for it. We'll cover those in a little bit. There's more than 25 million open source repositories today, and that's just on GitHub. So there's many different locations, many different places. Open source can come in from many channels in many different ways, and it's critically important, again, to have the process and the tooling in place to be able to control all of that. It is critical to understand the types of risks that you may be exposed to. So there's IP risk as far as making sure that you comply with open source licenses. Every package that is used has typically a license governing its use. There's obligations that come with that, and you want to make sure that as part of your legal compliance program that you're aware of the packages you're using, the licenses you may be exposed to, and what it will take for your teams to comply with those. There's also the security risk. There's vulnerabilities that may be in open source packages. If you don't know what you're using, it's very hard for you to mitigate those vulnerability exposures, and it's critical to be able to understand that. And then there's reputation risk. So every day we see a news story in the news about another security breach, and it's important to be able to control your company's exposure to that and be able to protect the company's reputation by having controls over the assets that you're using that other people have developed. So how does open source come into your organization? So typically, organizations are exposed on many fronts. You have partners that develop code. You have open source projects that you may be bringing in during build time. You may have code that you wrote that have snippets. So somebody looked at some sample code, pulled in a function, pulled in a method, and that may expose you to a vulnerability. You have suppliers that may be writing code for you. Open source materials can come in the form of software packages. They can come in through containers that you may need to stand up as dependencies to your application. They can come in as part of build dependencies. They sometimes will come in binary form. Sometimes they may be brought into source form and compiled along with your product. They can be in multimedia files. They can be copy and pasted into your code. They can also come from commercial vendors. Every commercial application out there typically has open source inside of it. It's important to not just trust that the application is clean, but to be able to vet it, understand what open source the commercial code is using, and then be able to manage that as well. And each of these entry points will thereby require different types of remediation. In some cases, you may have your own development team fix issues. In other cases, you may just upgrade to a newer version of an open source package. In some cases, you may have to go back to your vendor and get a new release of a commercial application. So where do we see the state of the industry today? So there's been a few bellwether events, most notably Equifax back in 2017. So there's close to 150 million people whose information was exposed. And it all resulted ultimately from lack of process. It was based on a component that has always been considered safe. It was under a permissive license. It didn't have any horrible vulnerabilities. And then suddenly one was discovered and a lot of folks were exposed. So the point to that is that just because something is clean today, it doesn't mean it's clean in the future. It's important to not only understand what you have, but also be able to manage knowledge about a package once your application is released. So we're seeing a lot of unmitigated risk. There's 50 to 80% of open source in a typical application, but based on our own audit software practices, what we see is about 4% disclosure rate. So only 4 out of 100 packages are known by our customers. And it's critical, therefore, again, to be able to understand the composition so that you can manage the risk that comes from that. We see folks moving to full stack analysis. So not only are people looking into applications they use and applications they ship, they're also looking at the environment that the application runs in. So they're looking at operating systems, at containers that are required to support the database, the platform, along with the application. So we are seeing the bill of material becoming much larger based on analysis of more materials. This is not a case of good versus bad companies. We're seeing this happening across the industry, different company sizes, different company industries. This is basically just an industry issue around getting a process in place and getting the tooling and support needed to be able to manage this like you manage anything else. And ultimately what we see is that the software supply chain lacks trust and transparency. There's materials coming in that are unknown to people. There's no processes in place to manage them, and therefore there's an industry problem. So why is this happening? So the number one issue that we see is that the use of package managers exploded years ago. And now where a developer writes some code and requests a third-party component to come in as part of their application, that component ends up pulling in their own transitive dependencies. And we end up seeing our bills of materials going from 100 items in audits years ago to over 1,000 items, which is common today. However, processes and tooling haven't kept up. In most cases, there is no process and tooling to support that. There's many packages coming in, the code is compiling, but people are unaware of the artifacts that are being pulled into their ecosystem. And historically, there's been little rein in engineering. This is one thing that we do see changing. We see engineers being more educated. We see companies being much more aware and having compliance programs in place to support it. And we're seeing a general accountability on engineering to be able to not just grab things from anywhere, but use a process that's mandated by their organization to control the materials that come into their company. So I will now hand it over to Martin. So Martin is from Source Code Control, who is Flexera's managed service provider. He will talk to you about how you can drive value out of your investment in an SCA solution and the challenges that managed services can address. Martin?
Many thanks, Alex. So there's various aspects to managing open source software. What we're focused on today, two key areas, managing licenses, license compliance, and intellectual property. And the other key area, which Alex touched on, is security, vulnerability management. Now, what I'd say to you up front is the whole discipline for managing those aspects of open source software are very, very immature. So if you were to maybe look to hire a person to manage this for you, you'll probably struggle to find somebody with all the skills. However, that is rapidly changing. As you'll see in this presentation, there are industry best practices starting as standards to demonstrate that organizations are managing the supply chain of software around open source software. So the types of services that we offer, we have discrete individual services, which we can, depending on a customer's requirements, mix and match to create a managed service. So the types of services we have training courses. Our flagship training courses Get It Right with Open Source Software, which helps standardize the knowledge within a company of what needs to be managed, what are the risks, and what are the strategies to implement in order to manage open source software. We help people with audits. We are involved in a project called OpenChain, which we're going to talk about, which is one of the best practices that has started. We help people create open source policies and processes for managing and implementing that process across the organization. And we can roll that up into what we call continuous compliance. So I'll finish off this presentation talking about what we mean by continuous compliance. Now, the need to manage open source software has shifted recently. Previously, probably about 12 months ago, companies could get away with maybe not managing open source software and still successfully sell whatever solution they're developing. But there's been some changes recently where there are actual requirements to demonstrate that software being supplied to organizations has a level of control for the risks that we touched on, security and intellectual property. Now, we focus on business as opposed to just working in software development. Now, the impact of not managing open source software can manifest itself in a number of ways. The value of a company, so say a mid-sized tech organization who have software as part of their solution, if you look for funding or look to sell your organization, it's become standard practice to do technical due diligence on the code, looking for any intellectual property risk, security risk, or bad coding practice, which might impact the return on investment of an investment. And that could be a strategy by investors to drive better terms, or an acquiring company to drive better terms. We're also seeing in the insurance industry where companies take out insurance for things like cyber and IP insurance. Insurers are getting wise to the risks with open source software and are looking for proof that companies have control of that situation. Alex touched on Equifax. So we're seeing fines by regulators. So in regulated industry like finance, there's an increasing risk of fines and alongside that, bad publicity from the exposure to the fact you've been breached by vulnerability or you've had an infringement of copyright or licensing. The final risk is around the open source community, where companies don't comply with licenses or go outside the ethos of open source software. The community can come together and cause issues for organizations. So for instance, there's a number of legal cases in Germany involving Linux kernel developers. So there's an ongoing case where a individual developer is taking VMware to court for modifying the Linux kernel and not sharing the modifications they've made and being adamant they won't share those modifications. So we're seeing an increase in those sorts of cases, so the community can affect the reputation of an organisation. What we see as a challenge for organisations in adopting strategies for managing open source software is driven by their own business. So if they've never managed open source software before, the challenge is twofold. At the technical level, so the developer level, most developers are focused on meeting deadlines. I've never met a developer who is not chasing a deadline to deliver code. You know, with agile practices coming in, the pressure to deliver faster release cycles is ever prevalent. And if you can find some third-party code on GitHub or similar sites that address a technical challenge, you're going to use it. And if there's no boundaries to say what certain licenses you can use or to check for security vulnerabilities, that code's going to end up in the code that ships to customers. And then at the other end of the spectrum, you have the business dilemma. So businesses are trying to get solutions out the door quicker and quicker, drive value of the organisation, and they're putting pressure on developments to increase those release cycles. So when we first start working with customers who've never managed open source software, their number one nervousness is, are we going to disrupt the delivery cycle for software? And that's where managed services can come in. When we get to the end, when we talk about continuous compliance, you'll see how that can be achieved without disrupting developments through good processes. Now, the other thing that's happening is companies are being forced to manage open source software, particularly in regulated industries. So I'm going to give you two examples, fairly recent, which is driving this need to manage open source software and supply chain. The first one is GDPR, which is a regulation introduced by the European Union, but it has a global impact. So anybody with a solution coming into Europe will have to adopt the GDPR regulations. Now, most people think about GDPR from the aspect of it's about processing data and personal data and managing that data. Now, there is an Article 32 of GDPR which states you have to ensure a level of security appropriate to risk. So if you're developing a solution where data is being processed, then if you have third-party open source software with known vulnerabilities, i.e. it's an avoidable risk, and that risk is exploited and you leak data. So Alex mentioned Equifax. Equifax breach was pre-GDPR. But if it was today, you'd also be in breach of GDPR and the fines would be even bigger. Bear in mind that the fine so far and the cost to Equifax is estimated to be $4 billion and counting. That's one example. Another very recent example is if you work in the finance industry or process payments through your solution, the Security Standards Council, the PCI Security Standards Council, only last month have published a new standard for securing the software lifecycle in software development. Now, it's quite a lengthy document, and it specifically calls out managing open source software as a requirement. I've just pulled out a section on this slide for the test requirements. So you can see the bullet points. You need to have an inventory of open source components used in the software. So that will be termed a bill of materials, a process to analyze those components, and a patching strategy for those open source components. So whether you're outsourcing software development or you're developing a solution, you'll find more and more that regulation is forcing you to manage open source software. So our advice would be manage it today rather than be forced to manage it tomorrow. So initially, a company would look to maybe manage this in-house. Where we see that failing potentially is mostly around education and also who owns the problem. So is it a business problem or is it a technical problem? Because it involves code, most companies see it as a technical problem and task developments to self-manage. But as I've already covered, the outcome of issues become a massive business problem. So first of all is defining who's going to own the problem, and it should be both business and both technical. Secondly, we see there's no clear success metrics. So what does success look like? What are the metrics to measure that success? Generally, it's quite vague. We need to identify components. We need to fix security vulnerabilities. So it's quite vague. We might see that somebody's chosen to, or is tasked to investigate the problem and create a strategy to manage that problem. So generally, it's not a full-time job. So maybe it's a developer or somebody working in software development. Maybe it's somebody more managerial, but it's not a full-time job to manage open source software. So they go off and investigate the market, go to events, and try to come up with a strategy. We also find there's a lack of budget to implement tools and things like that. And talking about tools, if it's left to development to sort out the problem, because they view it as a technical problem, they will look to adopt a tool. Now, the problem with not understanding the fundamental issues being managed, such as all the various open source licenses, is you buy a tool, you get a load of data, you can't interpret the data, and you might perceive a lack of value from the tool. We've seen companies buy a tool, use it for 12 months, maybe do a few static audits, maybe remediate some vulnerabilities, and don't see a value in the tool. And as the cycle comes around, they feel the tool isn't working for them, and they try and adopt another tool. So you're kind of wasting money on unnecessary investments in technology. So all this lends itself to getting outside help, and it'd probably be quicker to do that, and that's where managed services come in. So now we're going to talk about getting it right with open source software and what we refer to as continuous compliance. As with most solutions, it's going to be a combination of people, technology, and processes. So we talked about the people elements, i.e., is it just for development? Is it a business problem? So it needs to be a combination of all those people and potentially outsourced managed service providers providing some of those people initiatives. From a technology perspective, you've got tools like TextNet Code Insight, which can identify all the components. But like I said, if you can't interpret or you don't adopt processes to get the most out of that data, you probably feel like your project has failed. The key area is around processes. Now, up until recently, there was very little guidance for organizations about what processes should be put in place to manage that supply chain of software. That has changed in the past couple of years. There's this initiative called OpenChain, the chain referring to the supply chain of software. Now, OpenChain is a Linux Foundation initiative, and it will become an ISO standard probably within 12 months. Now, OpenChain is a collaborative project. Various organizations invested in open source software have come together, each with their individual programs for managing open source, to try and standardize and document what is the best practice approach to managing that supply chain. So what it boils down to is 5 key areas. First of all, as an organization, not individuals within the organization, but as an organization, do you understand your responsibilities and obligations for the open source software being used in your solution? Who's responsible for managing that? Is it an individual? Is it a team? Or is it outsourced to a third party like us? Or a combination of the above? Can you identify all the third-party components in your code, which is basically software composition analysis? And when you ship your software, are you meeting the obligations of the licenses? So things like license notices, attribution notices. If you're sharing your code, are you doing that in the correct manner to comply with the licenses being used? And the final piece, which is more optional, if you're contributing to open source projects like the Linux kernel or vice versa, if you are creating a community project, have you got a structure around that? Now, there may be pockets of information within OpenChain that an organization has in place, or people that could provide some of that functionality, but what we find is most companies don't have that knowledge. So they turn to companies like us to help them do that. And OpenChain as a project has recognized that challenge for organizations. So they've created a partner program. So you see we are one of the service providers for OpenChain. So we've helped a number of organizations achieve OpenChain conformance, and that's one of our managed services, which ties into the continuous compliance aspect of managing open source software. So now I'm going to talk about what I mean by a managed service and creating that environment for continuous compliance. So generally we go on a journey with customers, and most companies that engage us or we engage them are starting at the beginning of their journey. However, some companies may have elements in place, like they may have a policy, but it's not really working for them. So we go through a journey, and it always starts with education. We find there are misinformation about understanding about open source software. I thought you could do this with this license, or we never allowed GPL license and things like that. So our training course covers what are the risks, how do they manifest themselves, what needs to be managed, all the different types of licenses, and how do you manage it with continuous compliance. So we try to have all the stakeholders involved in the projects go through that course. So everybody's on the same page with regards to their level of understanding of open source and what needs to be managed. And also it helps get buy-in from people who may be not convinced that it's the right thing to do, or there's a right investment to manage open source software. So education is always the start of the journey. And that leads on to, well, we need a policy. We find smaller tech companies feel a bit intimidated by referring to a policy. You know, with two small organizations have policies, that's for big organizations. So we try to call it things like a guide for developers, if that's the case, but basically it's a policy. And that policy could vary by product line if there's different products that a company ships. So in some cases, you might be happy to share code and have a community project. Other cases, you might have intellectual property you want to secure and you don't want to share your code. So the policy will define all those boundaries. What it boils down to from a licensing perspective would be a whitelist, blacklist of licenses, acceptable or not acceptable. And then the next stage is, well, how do we identify all those components within the code? So as Alex talked about, the need for software composition analysis, accurate data of what components are in our code, what libraries are being used, how they're licensed, what versions, and other vulnerabilities. And we always try to then lead on to an element, a large proportion of self-management. So we never try to lock companies into our service, and we try to enable this self-management so it's non-invasive and doesn't disrupt particularly release cycles of software. And then the final piece that we offer is independent managed reports, which are for maybe management meetings to demonstrate that there's no risk going out to customers or risk to the organization downstream. So if we think about what that looks like from a developer's perspective or a development cycle perspective, this is a very simple interpretation of a DevOps process. So you've got developers developing code, using third-party components from sites like GitHub, Bitbucket, that's been merged into the code, and you've got continuous delivery, continuous testing. Companies who don't have a strategy for managing open source software will probably 99.9% be shipping some of those components with security vulnerabilities and with licenses that present a risk to the intellectual property of the organization. So the first stage of going into a structure of managing this is that creation of a policy, which we've already touched on. So what is the strategy of the organization? What is the intellectual property strategy? We never want to share our code, or we want to create a community project, so we do want to share our code. So defining that strategy, who are the stakeholders who are responsible for this? So maybe create a team, which is generally referred to as an open source review board. Maybe it's an individual, maybe it's a third party and an individual. So sometimes we play the role of advisor for some smaller organizations. What is the scope? So what applications are covered? How do we apply and enforce the policy? How do we deal with contribution? So if you're either contributing to external projects or having people contribute to your project, how do you manage that? And how do you communicate to end users all the obligations such as license notices? So where we see problems with policies is it's seen as a static document. So a one-off exercise creates an open source policy, but it's a living and breathing document. There's new licenses being brought to market all the time. We have components changing licenses between version numbers and new issues coming into the world of open source. So, for instance, MongoDB recently changed their license. If you had a solution leveraging MongoDB, that might be an implication. We also saw Redis Labs create their own license, the Commons Clause license. And obviously, if you're using Redis Labs technology, maybe you've got a cloud solution, then that could have an impact. So the policy should be continually reviewed for new issues, and that's part of the managed service that we offer. Most companies haven't got time to be keeping on top of the latest trends, particularly around licensing, so we take that pain away from them and continually update that policy. So once you have a policy, you can move into this self-management phase. Now, if you adopt a technology like FlexNet Code Insight, where you can scan the code, you have a choice. You can do static audits, so a point-in-time audit. So we've had companies who come to us and say, we're about to release a product. Can you do an audit before we release in case there's any issues? And if there are issues, it gets sent back to development. That's not a very efficient process. So the self-automation is you can, first of all, if you've got a policy, you can hardwire that policy into FlexNet Code Insight. So if you've got a blacklist of licenses, so in any circumstance, we can't use copyleft licenses, you can blacklist those within FlexNet Code Insight. If there's certain components or libraries you don't want developers to use, so for instance, the framework behind Equifax vulnerability was 2 vulnerabilities in Apache Struts. You might say, we never want to use Apache Struts, so you can blacklist that. You can flag and blacklist. You can't move forward in the development process if you've got vulnerabilities or you've got vulnerabilities over a certain severity. So the paper policy becomes a software policy within the code, within the software composition analysis product. So, and then you can integrate the software composition analysis into the build tools developers use. So right at the beginning of the software cycle, if a developer has got a technical challenge and finds some code, say on GitHub, which addresses that challenge and tries to use it, and it's got a license that you don't want to use, you can get alerted to that right at the beginning. So proactively, you're avoiding engineering risk into your software. And then the developer can look for an alternative solution. Potentially, you could contact the developer of the component and request another license. We've seen companies do that. So all through the development cycle, testing, user acceptance testing, the final build, you can get a report on what's in the code and is it in line with your policy. So the final build analysis, to all intents and purposes, should be a checkbox exercise. So now you're moving towards proactive, continuous compliance. So on top of that, to aid customers and give some confidence, particularly to management, that despite having that in place, there's still no risk. What we offer as a service is that every every software release, regardless of all those checks happening throughout the development cycle, we will go in and do a detailed audit of the software and provide a summary report, time-stamped. To this date and time, there were no known third-party component vulnerabilities. From an IP perspective, it's in line with our policy, and that can be shared with customers, prospects, partners, insurers, as a demonstration that you are managing proactively risk in your code. Now, obviously, there could be a new vulnerability posted as soon as that report is generated, so it's a continuous process. And then when you provide a fix, you can get an updated report. We also, on a regular schedule, down to the clients, we just provide a one-page summary management report. So not a technical report, kind of looking at, in the past 30 days, if say it's a monthly report, past 30 days, there's been 5 new vulnerabilities which are in our code. The date developments were made aware of it, which can be tracked in FlexNet Code Insight, and how long it took to fix. So one of the areas in the policy that we typically put in is a defined service level agreements for resolving security vulnerabilities. So for instance, if it was exploitable, it might be a hotfix, say within 48 hours. If it's a vulnerability that's there but not exploitable, maybe it goes into the next release. So that can be tracked and summarized in this management report. And as an example, one of our customers, the chairman of the company, who's not technical at all, they went through some issues around an acquisition, and that now he mandates every board meeting, he wants one of those reports on the desk to go through, that they're not creating any risk that's going on to their customers, which might be a risk to them as an organization. So that's all part of the managed service. And like I said, some companies may have some of these skills already, so we can mix and match and support where there's weaknesses in the service. So we could also offer, say, an assessment around how they stack up against OpenChain. So there's a definition, so we can do assessments and say strong in some areas, weak in some areas, non-existent in some areas, and it focuses the company on what needs to be addressed and what could be managed better. Now, this is a series of webinars. The next webinar, we're actually going to talk about a case study of one of our customers. Now, our customers range in size and in industry. So our smallest customer is 5 developers. You would think a small organization wouldn't be looking for a managed service, but they see a value in a managed service. Our largest customer is a global engineering company. So what I would say is it's relevant to whatever size customer. If you're shipping software, then the risk is the same whatever the size of the company. So the next webinar is going to be an actual organization we've worked with, taking them through the journey I've covered today, and you can hear from them the journey they went through and the value they're getting from a managed service. So with that, I'll hand back to Alex and Stacey.
Thank you. Yep. Thank you, Martin.
Okay.
So by far, the number one question that I hear both in pre-sales as well as when we have a new customer starting to deploy is, how do we do this? Right? We bought the product. We think we have some idea of what we need to do, but how do we operationalize this? So one way we just covered, right? Managed service is great. You provide requirements and you basically offload the operational part of this. But what elements go into the operational part? So I wanted to talk about things to consider and how to go about actually deploying such a solution. So when we talk about kind of the what's of the getting started part, there's 4 things that we consider to be critical. Number one, you need to understand your culture. And this will vary quite a bit between organizations based on size. So if you have a small startup, typically it's going to be homogeneous. They will be like-minded people. They will typically not have a lot of products. So it's a little bit easier to be able to put them in the right box. If you have a large organization, this will vary a lot by divisions, by business units. So it's critically important to understand, are you security-minded culture, meaning do you care about foremost vulnerabilities? You don't have an option of not looking back, right? You have to find every security problem and fix it. If you're a compliance culture, you may have an option to say, we're going to start this point forward, we're going to create policies, we're not going to look back, and we're going to put a process in place looking forward. That is typically not an option in a security context. Or maybe you're just a good enough culture where you're going to do whatever you can do in an automated fashion. That's all you can really put into your process, and that's going to be good enough, and perhaps once in a while you will go ahead and obtain an audit to be able to re-baseline you. So it's really important based on the culture to determine what is your level of acceptable risk, how much tolerance do you have, how much detail do you need in your policy, what your processes are to be able to deal with issues. The second thing is you need a solution that provides four things. So number one, you need traceability. You need to understand what people are doing, who did what, who made a change, who made a decision, so that you can unwind that if there's an issue. You need observability, right? You need to be able to have transparency and be able to see what's going on in the application, where you are at any given state. So you need dashboards. Martin mentioned there's a monthly report that they provide. So people who are paying for a solution need to understand that there's value being delivered in a continuous manner. And the third thing that's critically important is alerting. So as we talked both about Equifax, the issue there was it was a component that was considered green and suddenly became bright red and nobody knew. So alerting, just because something is okay at time of review or time of discovery, doesn't mean a month later that there are no new vulnerabilities, or perhaps there's a licensing change and you just did a silent upgrade with a new build. So it's important to have knowledge about the component even after you release an application. And then remediation. What are your standard plans to be able to deal with the various types of issues that you may discover through this program? What do you do if you find a license that's against your policy? What do you do if you find a vulnerability? Do you have to fix every vulnerability? Do you have to fix vulnerabilities of a certain severity or score? All of this needs to be identified in the policy, and there need to be concrete plans on what to do if that occurs. As mentioned during alerting, you got to handle the element of time. Things are not static. Things change. Licenses change when new vulnerabilities come in. Components age out. Components fall out of favor. Repositories fall out of favor. So it's really important to make sure that you're not on any stale code. And then probably most important to have success in this solution is you have to treat compliance issues just like you would treat any other bug. This cannot be a second-class citizen. This has to be treated with the same prioritization criteria, with the same level of severity as you would treat a bug that breaks your product. And if you don't get that buy-in from engineering, then compliance issues always get pushed to the bottom of the stack. So how do you do this? Typically, again, this will vary a little bit depending on company size, but typically what we talk about is kind of land, expand, and go deep. So it's going to be very difficult to put a program in place where day one you're scanning every single line of code in an organization. So what you would want to do is you want to either identify a couple pilot teams to get started with, if there's multiple products, or identify people that are willing to go through the education to understand how this program is put in place and what the success criteria is. And then what you want to do is try to get as many people involved so you get kind of a sense across the organization of where the trouble spots are. And then you can make informed decisions on where to go deeper. So you definitely want to develop your policies. Your policies are there for two reasons. Number one, they are there to ensure that things don't slip through, both from licensing as well as security side. But they're also in place to increase the level of automation. So if you have a scanning solution like ours, you scan, you find a component, you don't need to spend manual legal and security cycles on reviewing an item if there's a policy in place with the appropriate criteria. So that saves manual time, saves throughput, and allows you to have a system in place that's operating and delivering value without having people come in and do a lot of manual work. The next part of this is to put in an SCA solution. And the solution ideally is integrated into a couple different places. Number one, it should be integrated into your artifact repository. So the first time new artifacts come into an organization, they typically end up in a repository. The repository typically has a policy around it. It has allowed usages of who can use which assets. And then when various teams build their products, then the build will actually pull artifacts from the repository. So as early as possible, you want to get an identification that something is against your policy. You also want to enable developers to do their own local scans if possible. Right? The sooner you find out about a problem, the easier and cheaper it is to fix it. So developers, before even checking in code, would have an opportunity to do a scan, see if there's any egregious violations, and then address those before things get checked in and go through a build. And then ultimately you want to tie into your build. There's different types of automation that can be done. can automate into a continuous build system, into a nightly build, or perhaps you have periodic audits where you re-baseline and get a new established known source of truth. You want to focus on automated discovery across your enterprise. So go as wide as you can. You may not want to go very deep to begin with, but you want to get a sense of, do we have areas in our organization that have more risk than others, and then manage by exception. You don't want to look at every single item. There's going to be thousands that come out. That's why you have policies. That's why you have things that have been pre-vetted as acceptable based on your tolerance level. You want to standardize remediation, right? You don't want teams being kind of left hung out to dry to determine how to fix something. So ideally you have a centralized policy on how to do things, and then each team has autonomy to understand how to comply within that policy. And then you definitely need the ability to go deep where the risk is high. You may start by going deep in the first project. You may scan across your entire organization and then determine where the risk is and then follow the risk and be able to go deep. There's very often going to be findings beyond just packages. There's IP issues that can come out of individual files, images, icons. So therefore, it's critical to understand all the assets in your organization, not just what the package managers pulled in. So I want to spend one last moment on the product. So we do have a solution. Martin mentioned it, so FlexNet Code Insight. There's really three things that I typically talk about. Number one, easy on-ramp to automated scans. It can plug into an existing process in various places. There's a push-button capability to develop a bill of materials as part of your build. It allows you to manage both licenses and vulnerabilities. There is a policy engine in place, so all of the policies that can be developed as part of managed services can be put into the product, can become active, become live, can be revised as things change, and can give you insights into where you may be exposed. It's an on-premise solution, so it runs behind your firewall. It does not send any of your code outside your organization, so it maintains security for the code that you write. And it does provide continuous monitoring. So again, very important that just because something has been approved doesn't mean that it's good to go in perpetuity. Things change, licenses change, new vulnerabilities come in. So it's important to have an alerting element to the solution to let people know when something goes out of compliance. Okay, thank you very much. Stacy, I'll turn it back to you to see if we have any questions.
Thank you, Alex, and thank you, Martin, for that great presentation. Just as a reminder, if you would like to ask a question at this point, you can just type it into the chat function that you see on your panel there, and I will read it out to Martin and Alex. A question that just came in, and Alex, I guess this is more pertinent to what you've just presented, is is the approach to open source scanning different based on the size of the company?
Sure. So yes, good question. So I don't think the approach is different. I think the operationalization of it is different. So typically smaller company, less product, less people, less differing opinions, less incompatibility to policies. So in that respect, it's easier to get through the code. If you have a large organization that has various business units, some build cloud applications, some build distributed software, some have internal use, company sells worldwide, so there's export ramifications. The process to get everybody aligned, to get folks, the key stakeholders involved, is typically a longer process. So you typically want to go through a slower rollout across the organization. But the fundamental elements of how to roll out the process is exactly the same.
Okay, great, thank you. Another question that we have is a managed services approach to scanning or software composition analysis an all or nothing program, meaning can we customize it? And if so, what's the best practice there? What are your recommendations?
So I guess I can pick that up. So I tried to cover this in a presentation. Every company is unique. Every company's got different skill levels and people at their disposal who can manage this. So we always take a bespoke approach, but the fundamental building blocks are the same. Education is always key. So even if you've got some skills in-house or some people resources, the consistency of knowledge is probably varied. So then you've got challenges of differing interpretations. So you adopt FlexNet Code Insight and you find certain licenses one person says it's a risk, one person says it doesn't risk, go around in circles and no decision is made. So we have to make it bespoke. And also, like I said, we try not to lock people into our service. We always try to make them self-managing, and we fill in the gaps where they haven't got resources. So as this industry matures, you'll find more people coming in with skills, more people getting educated, and probably in 5 years' time you might find people doing this as a full-time job. But as things are today, third parties are probably going to be your answer in managed services.
Thanks, Martin. So we just had a question come in that is, what is the average timeline for rollout throughout a global organization?
Of the tool or is managed service or both, I suppose. I'd say it's quite, depending where they're at in their level of understanding maturity, if you look at it from a global perspective, it could be quite slow. We've worked with a couple of, and are working with a couple of global organisations. Generally starts at a business unit level or a subsidiary level, builds a success story, like a model that works, and then expand out beyond that. The risk is you try to achieve too much at the beginning, you don't get much success, and the appetite to do this drives away. So, you know, it could be 12 months, it could be 2 years. But to do one business unit, and if you're successful with that, makes it kind of replicable across the business as a best practice, then it will be quicker. So I can't give you a hard answer on it. It varies by organisation.
Okay, thanks. And I guess the last question that I see here is, what are the benefits of combining the managed services approach to open source risk management with periodic audit services? Is that truly the best practice approach?
Well, it's the most efficient approach. So as developers develop, you've integrated Code Insight into the build tools. You've got the policy guiding them. I always think of a policy as think of driving down a highway and there's a cliff on one side and there's no barriers. Then no policy, you might go over the edge. And the policy is like the arm code barrier, stopping you straying off the edge. So that way developers on a day-to-day basis are avoiding risk to all intents and purposes. Something might slip through the net. So there might be a new license or a component that's never been seen before, which might be missed, by, say, Code Insight. And then the audit is generally a slightly deeper audit, picking up any of the stray issues and like a double check. So like I said about the continuous compliance, the final build analysis should be, to all intents and purposes, a rubber stamp. But then the final, so we do the independent analysis. Is the independent report. And one organisation we work with, they themselves use this term. We don't want developers marking their own homework. So we have seen that there's been evidence of developers have some code they want to use, but it's blacklisted from a license perspective. And so they go in and edit the license to get around the policy. So we would pick that up with Code Insight. So with Code Insight, you can look at code snippets and actually pick that up. So it's that double check, if you like. So developers not marking their own homework, if that makes sense. Right.
And the final question I have here is, how do you get top-down support for this kind of open source management strategy, software composition analysis strategy within your organization?
Yeah, so that is a big challenge. So we do take a top-down approach. So we do, like I said, we talk about business risk. If you talk to, this is not unique to this industry, if you talk to cybersecurity consultancies, they will always say to you, they talk to companies for months, years, and they go, yeah, don't buy a service. All of a sudden they have a breach. Can you fix the breach? Can we buy your service? So it's like the horse is already bolted. So what's changing is there's more and more evidence of issues being created by open source software, both licensing and security. Alex has touched on Equifax, and I touched on Equifax. That's not a unique example. The issue with Equifax was in a component called Apache Struts. If you read the government report on Equifax, the CIO said at the time of the breach, we didn't even know we were using Apache Struts. About a month later, Alaska Airlines had a breach through Apache Struts, cost them $2.5 million. So there's more high-profile cases of vulnerabilities. And I think Alex could probably vouch for this. They would have had a spike of interest the day after Equifax breach was announced. And likewise with security vulnerabilities. So the way to build the business case is evidence. I've got a folder full of legal cases around licensing and security vulnerabilities. And the other thing that's changing anyway is there's more and more regulation, like the PCI regulation, where it actually calls out the need to manage open source software. And things like OpenChain, where you can get a certification, which will be an ISO standard. In order to be OpenChain conformance, you have to be able to identify all the third-party open source components and should provide documentation. So those things are changing that mindset. So the value in a badge that says we're OpenChain conformance is a business value, not particularly a developer value. So if the business wants the badge, then they need to adopt and invest in the processes. So the course that I mentioned that we've had CTOs, CEOs, contracts managers, legal counsel come on the course, senior solution architects, and they all, the common thing we hear at the end of the course is, 3 hours ago I didn't have a problem, I think we may have a problem now. So it's, people don't know what they don't know. So it's knowledge and awareness of these issues.
Okay. I think that's all the questions that we have. So thank you again, Alex and Martin, for your time today, for that great presentation. And thank you everyone on the phone for joining the webinar today. As a reminder, you will get a follow-up email with the slides and the replay of the webinar that will be available on our website. And with that, we'll end the call. Thank you so much.